Okay, so let's go over chapter 2. Let's go through chapter 2. So everyone has this handout. The solutions for this are online. This is online. Cool. So relations and functions. So what does it mean to be a relation? Like if you're related to someone, there's something in common?
Yes, ma'am.
So, yes, blood, if you're related. Okay. Versus if something is like, local to it, is near it, close to it. But that's a little different. Relations are a little different than functions. So relations just have to have something in common. But a function has to pass the vertical line test. Right? So a function, you have to only have one y value per x. Okay. So let's go through number 3. Don't say it out loud. You're going to do this in your head or on your paper. Is this a function? Don't say it out loud. Is this a function? Think about what does it mean to be a function? Is this a function? All right, on the count of 3, we'll say yes or no. 1, 2, 3?
No.
Yes. It is. There is only one y for every single x. We have no repeaters, so it is a function. Yes.
There's 2 zeros.
We can't have repeater x's. We can have repeater y's, but not x's.
Number one would be no.
Right, number 1 is a no.
Oh.
Because we only can have one y per x. But notice I'm picking 3 and 4 because this is the way I'll ask you, not 1 and 2. What about number 4? Don't say it out loud, but is this a function? How can we test it? Okay, on the count of 3. 1, 2, 3?
Yeah.
Ooh, we got some varying things.
Yes, no, it's no because it doesn't pass the vertical line.
Okay, Cooper, say it one more time.
No, because it doesn't pass the vertical line.
Yeah, so Tala is going like this in the back. So it doesn't pass the vertical line test. If I draw a vertical line, it crosses twice. What's wrong? Yeah, I saw you doing this. Is that what you're doing? For this? Yeah, exactly. Vertical line test. He says that you do it. There we go. Vertical line test. So this is not a function because it doesn't pass the vertical line test. Okay. Graph each relation or equation, find the domain and range, then determine whether the relation or equation is a function. So I'll give you maybe like 10 seconds or so. Plot these points. Try to see what the domain and range are. So remember, it goes x, then y. This is one problem I saw in a couple tests, not putting x and y in the proper place, switching them. It's always x, then y. So -4, -1 is right here. 4, 0, 0, 3, 2, 0. So I have those 4 dots. So let's think. Is this a function? Yeah, because it passes the vertical line test. Okay, because you should know what vertical line test is. If I give you a graph, you should be able to say, oh, it does or does not pass the vertical line test, just like this. Maybe put a star next to number 4. This would be a very nice problem. I give you a picture of a graph, and you have to tell me if it's a function or not. If you look at your practice test or past test, especially for chapter 2, there was a question just like this. I'm known for pulling questions from past tests or like formatting. How do you review for this final? We're going through lesson by lesson, go through the final exam packet, go through past tests, quizzes, practice quizzes. I'm going to try to pull a couple more questions from previous stuff. Just like this last test you took, chapter 4, there was at least 2 questions from your homework. Yeah. The x squared minus minus plus 4x minus 21, that was directly, and then the 3x squared, whatever, the one with the coefficient, that was from your homework as well. Okay, so we drew this, we see it is a function. All right, it is a function, so let's list out the domain. So since this is a discrete, there's specific points, we just want to list out the domain and range. So my domain is just going to be -3, -2, no, sorry. It's going to be 4, 0, 2, -4, yeah, cool. -4, 0, 2, and 4. And then my range are just going to be the y values associated with it. So it'd be -1, 0, 3. Notice I only put 0 once.
You don't need to put it twice.
You don't need to put it twice. I already have it written here. Perfect. That's all we're supposed to do, right? Graph it, check, domain range, check, and then determine if it's a function.
Put it twice, does it count as well?
Yeah, because it's technically, like, why are you saying it twice? So we already have it included in the one. All right, let's try 6. Try graphing 6 if you have not already. Yeah, okay, so you can just draw maybe halfway, draw a line of yourself. Cool. So this is the chapter where we went over slope-intercept form, standard form, point-slope form. So that's a little bit later in chapter 2. But we know that the slope is going to be 2, and we know our y-intercept is -1. So I have a point at 0, -1. Right here is my y-intercept, and my slope's 2, so it's a rise 2 over 1, up 2 to the right 1. So if you connect them, you can make a straight line. So this is the graph of y equals 2x minus 1. So think to yourself what the domain and range would be. I'll give you a couple more seconds to try to figure it out. So turn to the partner next to you. If you're alone, just turn around. Maybe talk to Felix. What do you guys think the domain and range are?
What do you think the domain is though?
Number 6. Not number 6.
All real numbers.
Okay, so let's come back. Felix, you said all real numbers. Why is the domain all real numbers here?
I got this. It keeps going.
Keeps going in all directions. There's not an x value that you plug in that won't give you a y value. Let's go, maybe Dylan, what's the range here? Do you know the range?
All big numbers. All real numbers.
Yeah, it's all real numbers as well, because the arrows are going up and down forever. So then, is this a function, Caden? What do you think? Is this a function?
Yes.
Yeah, because it passes the vertical line test. Passes the vertical line test, so it is a function. Okay, so if you're done with these, we're going to try number 7. Try on number 7 and number 11. So I want to give you guys a little bit of time. Try on number 7 and number 11. So when I walk around, I should see you trying number 7 and number 11. Active participation.
Can we just
Right.
plug it in for x?
Exactly. That's all you do. You just plug it in for x. Just plug it in for x.
I can't see the thing.
What?
You can't see the whole thing.
What do you mean?
The question.
Find each value of f of x. It's on your paper. Yeah.
You said 7 and which one?
7 and 11. I highlighted the ones I want to go over today. Yeah. So number 7 is 5 sevenths.
No,
it's
5
1.
5 fives,
Oh my
which is
God,
over
oh my
1.
God, oh my God, where did I-
Perfect.
I really want
You know, 11 is 15.
Cool. So -2 times -6 plus 3.
So it's
12 plus 3, which is 15.
Are we going to spend more than one day on chapter 4?
No. So 1 day per chapter, then I have a day where, honestly, I think we will. That's probably a better bet. I don't think we'll be as productive if I say it's a free, question. We'll spend 2 days on chapter 4. Yeah. I think we need to, so. All right, do we have questions over 7 and 11? So that's pretty much 2.1. So as I said before, as we go through this, if there's a section you don't understand, this helps you narrow, and don't study harder, study smarter. Don't be spending hours and hours studying for this final, where you could spend less time, but actually study the things you don't know. Cool. What? Study for APUSH? Okay. 2.2, linear equations. Is that what you said? Yeah, cool. That's what I thought. It is what it is. Yeah. This is a tough class too. All right, 2.2. Skill. All right, linear equations.
I'm sorry, I didn't mean to
Did you say no?
what?
Did you say
I
no?
didn't. I
Oh,
just said, what? I'm so confused.
okay.
No, I thought you were
Jacob.
I'm trying to help you guys so you don't
just getting
spend
myself into a-
unnecessary amount of time. You should study for the final, but really focus on the things that will help you most. What?
So apparently Jacob was the king.
What?
Whatever. Whatever. Okay, 2.2, linear equation. So we're going to do 3 and 4. State whether each equation or function is linear. Right, yes or no. If no, explain your reasoning. Let's do number 2 as well. So is number 2 linear?
Yes.
What? So this is linear. How do we know it's linear? What do we have to look out for to be not linear?
If the x is more negative,
The x
power
is
of
in
something.
the bottom.
If it's on the bottom, or if it's being multiplied by y, or if it's in a square root, or if it has an exponent other than 1.
Mm-hmm.
Those are the 4 things. So number 2 is a function.
3 and 4 and
So 3 is not a function. Jordan, why?
x is in the bottom.
No, because x is in the bottom. Number 4 is this linear?
It's multiplied by y.
Multiplied by y.
No, because we have a product of x and y.
Wait, it's not linear if it's those things? It's linear.
Right, it's, so this is not linear
Oh, okay.
if these things happen. If it's under a root, or if it's on the bottom of a fraction, it's being multiplied by y, or if it has an exponent other than 1. Cool. Alright, so write each equation in standard form, identify A, B, and C. So there's a couple of rules for standard form, right? So clear out the old cobwebs. So standard form is ax squared, ax plus by equals c. Right? So a, b, and c all have to be integers. A has to be positive, and it has to be in that order. Yeah? Remember this?
So much.
No? Okay, well.
I didn't remember.
So out of
So on the bright side, I mean, you guys did pretty well in your chapter 1 and chapter 2 tests. So that part of your final, like, you should do pretty well. You know, one of the keys is reading the directions, and if it says show work, yeah, show work. Identify A, B, and C. Okay, so let's write it in standard form. Remember, it has to be ax plus by equals c. So I need the term with x on the left-hand side. So I could write this as 7x minus 5 equals y. If I just change the order a little bit, it'll make it a little easier for us. So I have 7x minus 5 equals y. So I need to move y to the left side and the 5 to the other side.
So we add 5.
So I'll add 5 on both sides and subtract y. So I have 7x minus y equals 5. So I subtract y on both sides and add 5 on both sides. The y's go away, the 5's go away. I'll be left with 7x minus y equals 5. And then it says you have to identify A, B, and C. So A was 7, B was -1, and C was 5. So some people miss problems in their homework, miss points in your homework, because for 4.6, the quadratic equation, the problem literally said state A, B, and C, and if you did not, you missed points on your homework. Make sure you read the full directions. What? 98? I don't know. For different tests. I don't know. Different class. All right, let's try this one. So I'm going to write this as 3/8 x plus 5 equals y. So I need to move it so it's x plus a y equals a number. So I'll subtract 5 on both sides, and I'll subtract a y on both sides. What are they doing? 3/8 x minus y equals -5. So we're done, right?
Yeah.
A, B, and C are integers. Right now I don't have an integer in front of x. 3/8 is not an integer. Yeah, throwback to Friday when we went over chapter 1. An integer can't have a fraction. So if I multiply every single term by 8, guess what happens to this first one? Cancels out. 3x minus 8y equals -40. That was good. B is -8, C is -40. So we had to identify A, B, and C and write it in standard form. Okay, do we have questions over standard form? There's a lot of things to remember. There's a lot of curriculum.
Oh.
So on your final, I mean, you guys will be in this room I'll have the poster. I think it'd be easiest if I just make an equation sheet.
Yeah.
Just like your chapter 4 test where I labeled what everything was. Like I'll write all the linear ones and I'll write all the quadratics for you.
Are we gonna finish teaching before class?
Do what?
Questions?
I'm sorry, what?
Are we gonna finish my others like before 15?
That's my plan. Yep.
It's a great plan this year.
That's my plan. I'm trying to have a good review of all the stuff. I don't know. I want you guys to do well. That's it. What are you doing? Texting over there, Dylan? I see you.
He goes back. Gotta see what that is. Dylan's so funny.
Okay. Find the x and y intercept of the graph of the equation. Then graph the equation. Okay. Find the x and y intercept. How do you find? This is one thing we missed on. This is one thing we missed. It's one thing we missed on the chapter 4 test. Shh. Kaylin, how do you find the x-intercept? What do you have to do?
You're gonna plug in 0 for all the x's.
For the x-intercept, you plug in 0 for y. For the y-intercept, you plug in x equals 0.
That's what I just said.
Okay, so let's find.
So 0 equals 2x plus 4.
No, y equals 2 times 0 plus 4.
Well, we're trying to find the x-intercept first.
Yeah, I know. So 0
So-
equals 2x plus 4. And you subtract the 4, and you got negative 4 is 2x, and so it's negative 2 equals x.
Exactly, negative 2 equals x. So that's our x-intercept. So this means at negative 2 comma 0, I have a point. Come
And then y
on.
equals negative 4 though.
So y equals 2 times 0 plus 4. So y equals
Negative
4.
4.
4. Positive.
Did you have a nice weekend, Miss O'Brien?
What? I'm trying to help you study for your final. We can talk about our like weekend not during class, right? So we're focusing. We're using our class time wisely. Think how happy future Caitlin will be. Future Caitlin on the 20th of December is gonna be like, wow, look at me, I rocked all my tests.
I only have one. So
Okay. Okay. Yeah.
Well, we won't know.
You have a week.
What is this
You literally
rule?
have a week until your exam. Let's study together.
Imagine not having finals.
So 0 comma 4 is your y-intercept. Shh. We found our x-intercept is at negative 2 comma 0. And our y-intercept says 0 comma 4. So to find y-intercept, you plug in x equals 0. This is a common thing you have to know for both chapter 4 and chapter 2. Yes.
Can you just graph from slope intercept right away? Yep. And you get the same answer. Yeah.
But what if I don't have you graph and I just give you the equation? You have to find the x and y intercepts.
But let's say if you have the graph. Would that
But
be enough?
let's say you don't.
Okay.
Okay.
I have to show it.
So what I'm looking for, like,
Sorry,
I'm
no.
looking for,
That graph, no.
you understand an x-intercept means a y value of 0.
Alright.
And a y-intercept means a x of 0. That's really what I'm trying to test for. Okay, let's try number 10 if you haven't already. I'll zoom over a little bit. Okay, so let's find the x-intercept. I'll give you guys a little bit of time to try this yourself.
Alright.
Can I do this problem, please?
Nope.
On
I
the
wanna
board?
do it.
You want to do
Oh,
this?
can I do it on the board?
You want to do this on the board?
Didn't you want to make sure I got through everything so you had questions? Okay.
Are you
So
testing my ability?
no, I'm literally just being like, hey, let's focus. So the x-intercept is 0, 7, because you plug in 0 for y, and then you solve to get x by itself. And so we have a point 1, 2, 3, 4, 5, 6, 7, 0. And then to find the y-intercept, you plug in a 0 for x. So 2 times 0 plus 7y equals 14. So you have 7y equals 14. Divide by 7 on both sides. You see y equals 2. So 0, 2. Right. This is our graph. Okay, questions over the second section.
No.
So we have 6 sections to go over. Kind of want to like touch briefly on all of them. The idea is to help you focus your study. What do you really need to go over? Okay, so number 3. I'm sorry, section 3. It's all about slope. So we're going to do number 1 together. I'll do it over here. So how do you find slope? Do you remember the slope equation?
Y equals MX
That's slope intercept, but that's slope intercept.
Oh, I know. Y
Point
minus
slope,
y
y
one
minus
equals
y,
x
y2 minus y1
parentheses
equals
x minus 1.
So it's point slope. Point slope. It's okay. It's point slope. Well, no, because if you think about it,
X2 minus x1.
if you think about it, if you took point slope, divide both sides by x minus x1. You see the part I'm talking about, the green part below? If you take this guy, if you take this equation and divide both sides by x minus x1, you have the slope equation. That's where it comes from. What is this noise? Okay. Okay.
Oh yeah, because you're dividing the x. Oh,
Yeah.
that makes total sense.
Change in y over change in x. So it might be easier. Oh, wait a sec. Okay. So it might be easier if I give you a question like this, you go through and you label what is what. That way you know exactly how to plug in. So our slope is going to be 2 minus 3 over negative 5 minus a negative 8.
So, are we taking the final here?
Yes.
Can that be on the thing?
What did I say about 5
Yes,
minutes
it's gonna
ago?
be there, Felix. And she's gonna give us an equation sheet.
Yeah, let's give you equation sheet where it's like listed. That way you don't have to crane your neck to look over.
You did the number.
What?
Minus negative.
You did
Oh.
y2 minus x1.
Yeah. Minus 3. Nope. Just a moment. Okay. 2 minus a negative 8 over a negative 5 minus 3.
Wait, is that clock wrong?
10, yeah, it is. 10 over negative 8?
Are the minutes wrong or the hours?
It's 254. So it's off. So 10 over 8, can we reduce this?
Yeah.
Yes. Your the
X
x
2 5 equals negative 5 over negative.
exactly. The expectation is you simplify always. Right? I shouldn't have to say simplify because we always simplify. Always simplify, we always simplify. Alright, try number 7.
Can I ask you a question by any chance?
Yes. Is it about this?
I don't understand that sign. Mathematics is not a spectator sport.
Yeah.
I'm on meds.
Yeah, like you can't just sit and watch. You have to like be active.
Where does that say that?
Right up here. The what?
I feel like I'm like.
Shh. Number 7 says, stop, focus. Graph the line passing through the given point, the given slope. So at 0, negative 3 is right here. And we want a slope of 3. So we start with our y-intercept. Yeah, and then you have your line. And that's all this one wanted. So try number 8 if you haven't already. We point at 2, 1. We have a slope of negative 3 over 4. So down 3 over 4. And of course, you only need 2 points to graph it. So if you have a straight edge, you could connect it. Alright, so this is dealing with, okay, so I have a point, you pick that point, and then to make a line, you just have one other point based on your slope. Here, negative 3 over 4 means down 3 to the right 4, where number 7 was up 3 over 1.
Oh my god.
So we're going to try number 9.
Wait, no, don't leave it.
I'm going to leave it up there.
1?
What's it look like? Flat. Exactly. A slope of 0 is a flat line. So I have a point at 0, 2, and the slope is 0, meaning it's going to be a flat horizontal line. Yeah. You know what? Let's do number 10. This is good practice. Number 10. Number 10. So at 2, negative 3, we have a point. Yep. Up 4. 1, 2, 3, 4, 5.
Wow.
Alright, just a reminder that we shouldn't have our phones. They should be in the holder. So don't have them out. Let's be focusing. I have 2 points. I just need a straight edge to connect them and I'm good. All right, do we have questions over these four? Because graphing is a vital part of doing this.
Wait, don't. Mine look.
I'll just move up a little bit.
No wonder something is wrong here.
That's okay.
I was looking at the wrong one. Silly Katie.
All right, if you haven't already, give number 11 and 12 a shot. Number 11 and 12. Try number 11 and 12.
Wait.
All right, so we're on 2.3. Do you want to turn to 2.3?
Oh, I'm so sorry.
Okay, wait. It's the bird. The bird.
See, Jordan, you want to turn to 2.3 so you can follow along?
Is that where you start?
Yep. Parallel, same slope. Perpendicular is opposite reciprocal. So if we want a perpendicular slope, this is my original slope. Perpendicular flips it and changes the sign.
Oh my god.
Because it's perpendicular. So opposite reciprocal, you flip it and you change the sign.
So it's negative 2.
So 3, 0, and then negative 2 down 2 over 3.
Wait,
What?
why is it? Oh, perpendicular.
Perpendicular. Versus parallel. So if we want a line parallel to another line whose slope is -1, guess what our slope will be here?
Positive one.
Parallel, exactly the same, -1.
Oh, what? But why is it?
Negative,
Oh, you
it's
flip
down
it.
1 over 1. You're always going to the right. Slope always goes left to right.
Flip.
-3, -1, and the slope of -1 just goes down 1 to the right 1.
Oh, shit.
Stop, come on, that was not nice.
That was hella mean, dog.
I didn't mean it like that.
This is like a private conversation. You should not have it in middle class. You should be talking about math.
Math.
Okay. Do we have any other questions over 2.3? Okay, so let's go on to 2.4. Yay.
No,
So-
I was using it to erase this time.
This is asking us to state the slope and the y-intercept of the graph of each function. So we want the slope and the y-intercept. So that's the intercepts. But since this is in slope intercept form, Right? You should think about future you. Think about future you. If you're about to talk and be disrupted, think about future you. Do you want to have a 0 on participation? Do you want to have a bad grade on your final? No. That's rhetorical. Both answers are no. We're focusing. So we want the slope, which is m, and the y-intercept, which is b. This is in slope-intercept form. So the slope for the first one's 8, and the y-intercept is 12. Or you could write 0, 12. That is also acceptable. Saying b is 12 or 0, 12 is your y-intercept. What about number 3?
Congratulations.
Come on. Number 3. What is the slope going to be?
Up 3, right?
Exactly. Close. So down 3 to the right by 5, because there's a negative sign. So that means go down. So our slope is -3/5, but what is our y-intercept? 0, because we weren't adding or subtracting any numbers.
So y equals 0 now? Oh, b.
B equals 0. B equals 0. What are you crunching? Okay.
Oh god.
Let's try number 4. Number 4. So I'll give you guys a shot to try this. So this one's a little tricky, that's why I picked it. So if I divide both sides by 3, we see y is equal to 7/3. What does this line look like? It's flat. Y is constant. Y is constant.
Because there's no y.
Well, no, y equals 7/3, so it looks something like this. There's no slope, so our slope is 0. Our y-intercept is 7/3. That's tricky. Alright, so we want to write an equation slope-intercept form for each graph, 7 through 9. How do you know it's y equals 2? There's no slope, because if I said y equals mx plus b, and my slope is 0, I have y equals 0 times x plus b. Well, 0 times x just goes away. Awesome. So try out 8 and 9. Don't yell out the answer yet. I want you to try 8 and 9. Yep. 3 over 2x minus 2. So the minus 2 comes from this b, which is our y-intercept. The slope is 3 over 2. Rise 3, run 2. Okay, so that's number 8. Try on number 9. Yeah, so negative 2/3 x plus 1. Yeah, plus 1. Because the y-intercept's 1.
Oh my god.
Down 2 over 3. Huh? So right here it says it's 3. So 1. So 1, 2, 3. Yeah. Okay, so we found the slope was negative 2, down 2, to the right by 3. And then our y-intercept was 1. Okay. Questions over these ones? So, I want you to try number 10. We're going to write an equation in slope-intercept form for the line that satisfies each set of conditions. It was plus 1? Is that your question? Why?
Yeah, why?
Because the y-intercept is plus 1. The b value is 1.
Oh, I
Yeah.
didn't even look at that.
Okay, slope negative 5 passes through negative 3, negative 8. So what I'm going to do is use my point slope form, because I have a point, I have a slope, and once I have that, I can convert into slope-intercept. So remember, it's y minus y1, it's on the poster to your right, equals m times x minus x1, and I'll give this to you on an equation sheet for your final, but you do have to know how to use it. So you have to know how to use it. So I have y minus negative 8 equals, well, we said the slope was negative 5 times x minus a negative 3. So this is y plus 8 equals negative 5 times x plus 3. So we can distribute the negative 5 out. Y plus 8 equals negative 5x minus 15. And all I have to do is subtract 8 from both sides, and I'll have it as y equals negative 5x minus 23. So that's our point slope form. We use it to rewrite, right? We rearrange so it's in slope-intercept form. Questions about this one? Because this is, look over your chapter 2 test. Seriously, look over the chapter 2 test. This it's going to be very similar. I'm going to try to word the problems like I did on previous tests. Try number 12. Slope of 0 passes through 0, negative 10. So if I use slope point slope form, y minus a negative 10 equals 0 times x minus 0. Well, the whole right side goes away, so I have y plus 10 equals 0. Subtract 10, and I have y equals negative 10. And this is in slope-intercept form. Because it's a flat line. Once again, it's a flat line. Let me see which other ones I wanted to do.
What do you do for like 6? So there's only
Yeah, so we know the x-intercept has a y value of 0. So this is a point 3, 0. And we have a point 0, 2. Since I have 2 points, I can find the slope. The slope is, let's see, y2 minus y1 over x2 minus x1. So that's 2 minus 0 over 0 minus 3. So negative 2/3. And since we have the y-intercept, we can go straight to writing y equals negative 2/3 x plus 2. Because the 2 for my intercept is what goes on the right side. Slope intercept form. Okay. Cool. I think I printed the wrong page for 2.5, but it's graphing absolute value. So we're going to go to 2.6. Well, how do you know, like, okay, you can tell how the name of each kind of function can help you remember what the graph looks like. So the absolute value function is literally going to be a v, because it's an absolute value. That's the trick. Like a and c, what's the absolute value of negative 3? 3. Absolute value of negative 4.01?
4.0.
Yeah, so it just turns the negatives into positives. What if I took like b, right? Part b, what is absolute value of 6.2? Yeah, 6.2. It doesn't turn a negative, it keeps it positive, right? It keeps it positive. So I want to make sure that's clear. Absolute value makes things positive. If they're already positive, keeps them positive. And big thing that we remembered yesterday, if you have an absolute value, it can't equal a negative number. That will give you no solution. Absolute values always have to be positive or equal to 0. Okay, so let's practice graphing inequalities. So first step, I need to graph the line y equals 3. Is this going to be a solid or a dotted line? Solid, because it's an equal to. And then it's at negative 3. And in order to figure out which way to shade, I have to pick a point. So I'll pick 0, 0. And if I plug in, is 0 less than or equal to negative 3? It's not. So that means I'll have to shade the side where it would be true. So since the side I chose is not true, I shade the opposite side. Try number 2 if you haven't already. Try number 2.
You do 0, you just put a 0 out, whatever that is.
For my y? If it was true, I would shade that half where it is. Since it wasn't true, I shaded the other half.
So like it would be like in this week.
And so you never can pick a point that's actually on the line. Let's do number 2. X is greater than 2. So I'm going to draw a dotted line at x equals 2 because it's only a greater than. And I'm going to just pick a point to plug in. So I'll pick the left side. Is 0 greater than 2? No. So that means I have to shade the other side. So we're going to do number 4. So, first thing we ask ourselves, is this going to be a dotted or a solid? Dotted. How do you know, Tal? Because it's not equal to. So, it's also an inequality, which means you have to shade. Literally, half the points of the problem are shading. Don't forget to shade if it's an inequality. So, it's going to be dotted. I have a point. I have my y-intercept at 5. And I have a slope of negative 3. So I go down 3 over 1. Down 3 over 1. And it's going to be dotted, dashed, as long as it's not solid. And then you can pick any point on your graph. Any point, as long as it's not on the line that we just drew. If you plug it in and it's true, we know we have to shade that side. I like picking 0, 0 because it's super easy to plug in. Gives me 0 less than negative 3 times 0 plus 5. Is 0 less than 5? That's true. So I will shade the half where this is. Since it was true, I shade the half of the point that I plugged in. Okay, I want you guys to try number 5. Try number 5. So it's dashed because it's not an or equal to. We have to pick a point. So I'll pick 0, 0. Is 0 less than 3? That's true. So I shade this half it's on.
I don't know why this felt like it was hella harder when you first did it.
Well, it's pretty much a lot of things you're going to do in life. It looked like it was hard until you reach something that's harder, and then you're like, oh, it was easy.
No, but like I just remember this being really hard.
Oh, well, if it feels easy now, then that's solid. Okay, so those are the main 4 I wanted to get through. The only thing we didn't get through today was graphing absolute value. Let's make sure we do it tomorrow. We're gonna make sure we graph absolute value. Okay, I'll see you guys tomorrow. Have a good rest of your day. Don't forget to do Alex. Do Alex.